This is number 26 in packet 47. Okay, let's go. So we want to make a TM a median. So our goal is to make RM congruent MS. Okay, and since these two triangles, that is these side are part of, don't look congruent, so it's not going to work. So we have to make these two congruent first, so that these are corresponding side. And then we're going to make this triangle isosceles. And to make it isosceles, we have to prove that these angles are congruent. Okay, so that's the goal. Okay, right. So one, we start with this one. So MN is the perpendicular bisector of TS. So then, if that's a perpendicular bisector, then angle, should we do measure of angle? Yeah, measure of angle MNT equal measure of angle MNS equal 90. Okay, and perpendicular lines form 90-degree angles. Okay, and so 3 angle MNT is congruent to angle MNS, or the angles with equal measure are congruent. If I said these are right angles, then all right angles are congruent. But since I said 90, this is angles with equal measure are congruent. Okay, so I got the, I made these congruent now, right? And then also this is a bisector, so these are congruent, right? So we have to say that. So we got the angle here. And then for Tn is congruent to Sn. Make sure you go in the corresponding order, and that it will be a side. And this is definition of perpendicular bisector. Alright, the not definition of perpendicular lines from, I didn't say perpendicular. Alright, this should be definition of perpendicular bisector too. Yeah. Alright, this should be definition of perpendicular bisectors. If MN is the perpendicular bisector of TS, then these angles are 90 degrees. That's the definition of perpendicular bisector. Okay, and then this is definition of a perpendicular bisector. There is a space between here, but you don't have to repeat this. Okay, because you have, this is the if line, and this is the then line. If MN is a perpendicular bisector of TS, then TN is SN, definition of perpendicular bisector. Okay, and then we got this congruent, these are congruent, this is shared. So segment NN is congruent to MN in that order, that's reflexive. So that would be a side. So you got the triangle MNT is congruent to triangle MNS, and that would be side angle side portrait. So now you got the MS is congruent to MT. And C, B, C, D, C. So far we got here and then here. Now we want to make these are congruent, so you can make these congruent, right? And so we have to make these angles congruent. So how do we do this? First, angle R and angle S are complementary. Two acute angles of a right triangle are complementary. Actually, I'm sorry, I have to say that this is right triangle first. So that's why two-column proof is a lot longer than paragraph proof. Paragraph proof, you don't have to do this. RTS for 90, that's given. And 9, triangle RTS is a right triangle. Definition of right triangle. If the measure among RTS is 90, then RTS is a right triangle. Or if one of the angle is 90 degrees, then triangle is a right angle. Any of those would be fine, or definition of right triangles. Then you can say that angle R and angle S are complementary, and two acute angles of a right triangle are complementary. Okay, so we got these are complementary. Okay, and then now we want to make this also complementary to this. Then the two angles complementary to the same angle or congruent angle are congruent. So we can make these congruent actually, right? Because those are CP/CTC. So 11. Angle S is congruent to angle MTN, and that's CP/CTC, right? So then 12. So these are complementary and these are congruent. So I'm going to make these complementary. Okay. So angle MTN and angle MTR are complementary because two angles form a right angle. And then we said that it's a 90-degree angle. Form a 90-degree angle. Because that's what we said here, 90-degree angle. Form a 90-degree angle. Okay, so they're complementary. So let's see what we got here. R and S are complementary, and then MTN and MTR are complementary, and then S and MTN are congruent, so we can say that, right? Angle R is congruent to angle MTR, and angles complementary to congruent angles are congruent, right? These are complementary, and these are complementary, and these are congruent, so they have to be congruent, right? Okay, so now we got the these are congruent, and therefore MR is congruent to MT, and that's converse of isosceles triangle theorem, right? Angle to the side is the converse. And then 15, TM is a median of triangle RTS. Well, I guess you don't need this. This is in parentheses because you don't have that here. See, and that's a definition of median. Okay, so that's, oh, sorry, you missed that part. Okay, TM is a median of RTS, definition median. So that's 15 line proof, and it took me 10 minutes to write. You won't get this long on quiz. Okay, I just want you to be able to do this at home.